Okay, welcome to this session. We're going to be looking at momentum. Okay, so the equation for momentum, and you'll get this on the equation sheet. Momentum is mass times velocity. So if we had a car with a mass of 1,000 kilograms, which is about 1 metric ton, and a velocity of 10 meters per second, we could use this equation. So mass would be 1,000 kilograms times 10 meters per second equals 10,000, and because it's momentum it would be the units of kilogram meters per second. Okay, now sometimes you'll see a question where they ask you what the momentum will be of a car stopped at the traffic lights, or a car that's stopped, or something that is stopped. And we know that if you've got zero velocity, which you would have if it was stopped, you must have zero momentum, because no matter what the mass is, anything times by zero would equal zero. Now, this starts getting a little bit more in depth when we're talking about a car that's colliding with another one. So excuse my poor drawings, but if we start off with, we've got two cars, and I'm going to draw this in the middle so that you can see this is before the collision. So this side is before, okay, and this side is after. Now, draw those two together so we can see that they're moving together. Okay, so this first car has a mass of 1,000 kilograms, just to keep things easy. This car has a mass of 500 kilograms, so it's got half the size, half the mass. Now, if this one is moving at a velocity equal to, let's say, 5 meters per second, this one has a velocity of 0, so it's stopped. So we can see straight away that this second car, or in fact we'll call it car B, has zero momentum, because even though it has a mass, it has no velocity. Okay, so if we want to work out the momentum before the collision, all we need to look at is this car here. So write out our equation again, mass times velocity, and it will be 1,000 for the mass, so 1,000 kilograms, times 5 for velocity, which will give us 5,000 kilogram meters per second. So that is the velocity before the impact. Now, because conservation of momentum, and I'll write this here, momentum before a collision is equal to momentum after a collision. So whatever the momentum is before is equal to the momentum afterwards, as long as no external forces act. Okay, so that means we can say that this side has a momentum of 5,000 kilogram meters per second also, because whatever before must be equal to whatever after, hence the conservation of momentum. So we know that this one has 1,000 kilogram mass, this has 500, so we can work out the total mass, because what we're going to do is apply this again, so mass times velocity to this side. Well, we know that the momentum is 5,000, we know that the mass is 1,000 plus 500, so 1,500, and we want to work out the velocity, which is quite often the sort of question you'll get asked. So first off, let's put our numbers in. So 5,000 is equal to the mass, which is m total is equal to 1,500. So it's equal to 1,500 times v. Now, if we want to rearrange this equation and make v the subject, we can do 5,000, write it out again, v, so 5,000 divided by 1,500, and divide this side by 1,500, So anything divided by itself is equal to 1, therefore those cancel out. And we're left with V is equal to 5,000 divided by 1,500. Okay, so how many 1,500s go in there? It's going to be about 3, okay, or 3 point something. So then we can work out what our velocity is, and that would be in meters per second. Okay. Now, also, when you're doing momentum, we talk about explosions, and I'm going to cover that in the next video. So hopefully that was helpful. If you've got any comments, please post them below. If you've got any questions, also please post them below. Thank you.